Hey guys, Mr. Riz here to help you out on the next section here in chapter 4. So we're going to be doing pretty much like what we just did in the last section, where we're going to be identifying the parts of the parabola, but we're not going to be given to it in vertex form. We're going to be looking at what's known as standard form. So a standard form of a quadratic function or the quadratic equation is y equals ax squared plus bx plus c, where we have some number x squared and some number b squared equals some, or bx, and then just plus some number c at the end. So if you want to go ahead and look at these two graphs here, we can see this first one. We can, say that a would equal 1 because it's 1x squared. B would equal 2. That's the next number. And c would equal -5. But remember, when we're looking at a parabola, some of the key features we want to find is the vertex, and that vertex is located at HK. So what we're going to do first is we're going to go ahead and graph these on Desmos, and we're going to sketch them out and then see if we can kind of figure out something special between the standard form and the vertex. So I'm going to try to leave these notes up here. Might get a little messy, but I'm going to open up Desmos graphing calculator. And let's look at that first equation. That first one was x squared plus, I have it written down here. So it is y equals 1x squared plus 2x minus 5. Okay, so we got a nice parabola here. It is a smiley face one, and the vertex is at -1, -6. If we wanted to get a couple more points, we can go ahead and convert this to a table. And you can see here, we got -1, and then that's actually where the axis of symmetry is. So we're going to do a quick sketch of this graph here. And if we're going to do a quick sketch, the biggest thing we want to make sure we do is put where the vertex is at, -1, -6, and it is a smiley face parabola. Okay, let's graph this other one over here where, all right, we're going to write A, B, and C. All right, A would be -1, B is 3, and C is 7. So once again, just using the graphing calculator, because remember, that's a tool we can use, but we're going to see if that can help us figure some things out. So it is y equals -1 or -x squared plus 3x plus 7. Okay, so this one is a sad face parabola, and the vertex is at, interesting, 1.5, 9.25. All right, so we'll just do, a quick sketch of the graph, what we're seeing here. All right, so, 1.5, comma, 9.25, I believe, and it was sad face. Okay, so let's see if we can kind of make some connection here between the standard form and our regular vertex form. Remember, vertex form was y equals a times x minus h squared plus k. Now, there's technically a mathematical process we can go through to convert this here, but in our class, we really don't worry right now about converting it, but can we find the key pieces? And we can actually do a couple things here if we look at a pattern. All right. What we have going on here is, if we look, our A is essentially the exact same A. And if we remember before, if A is positive, what we have is a happy face parabola, and the vertex is a minimum. And if A is negative, we get a sad face parabola, but that means the vertex is a max. Okay, so that still works in standard form. So if we give it standard form, we can follow the same rules of determining whether the vertex is a minimum or a maximum. The next question is, well, how do we actually find the vertex? Vertex is super easy to find in vertex form because we just take that number and that number. That's the h and k. All right, in this one here, we're going to have to look. Our h is -1. We have these numbers here. And then in this one here, our h is 1.5. All right, so I'm going to give you a clue if you can't figure this out. How do we go from these numbers here to -1? And how do we go from here, these numbers here to 1.5? Hold on one second. I need to help this kid out. Okay, so what we want to do, I know that was kind of a cliffhanger there. What we are going to do here is look, there is something that happens, and make sure you mark this down, that h is equal to -b over 2 times a. So if we look at this problem here, oh, yeah, go ahead, Kim. What we got, if we have our h, if we say it's -b, so our b is 2, over 2 times our a is 1, that'd be -2 over 2, and that reduces to -1. Over here, if we want to try to figure out our h, we'd have a negative, b is 3, over 2 times a is -1. That'd be a -3 over a -2. -3 divided by -2 is a positive 1.5. Okay, so that's how we can figure out our h's. Now to find our k is a little tricky. To find our k is we have to remember technically each equation is a function of x. And our h is a x number as a point. So what we can always do is we can plug in that x number into the equation to find k. So to find k, we're going to do f of -1 in the first problem because that's what our h is. So that means we're going to take our equation, we're going to change all of our x's to -1. So what's -1 squared plus 2 times -1 minus 5? So that'd be a +1 minus 2 minus 5. +1 minus 2 is -1. -1 minus 5 is a -6. And then there's our k. Over here, we'll do the same thing. I'm kind of running out of room, so I'm writing kind of small here. This is going to get crazy. We're going to find f of 1.5 to get our k. So what is -1.5 squared plus 3 times 1.5? Yes, sir.
Do you change your thought?
I do not. Sorry. Sorry. All right, best, no, good luck. All right, so 1.5 squared. We're going to square that. That's 2.25. Don't trust me. Use a calculator here. 2.25, and we'll make it negative. So that's a -2.25 plus 3 times 1.5 is 4.5, and then plus 7. So if we go through and add these together, I'm just going to do this. 4.5 plus 7, that's 11.5. 11.5 minus 2.25 give us 9.25 left over. Okay. So a big thing to help us out here is that what we want to do here is we want to find this vertical line to get this. And remember, our vertical axis of symmetry is x equals h. And maybe we'll make our note here that if we don't have h, if it's not given to us in vertex form, that h is equal to -b over 2a. So the turning point of that vertex is going to be the minimum or maximum point, and that's whether a is positive or a is negative. All right, so if a is positive, we have a minimum. If a is negative, we have a maximum. Okay, so let's practice these problems here together. So we're going to try to do this without graphing them on a graphing calculator. And then we're going to use a graphing calculator at the end to, see if we're right. So if you want to pause the video to try it on your own, you can. If not, I'm going to start with problem 3 here. All right, problem 3 here. I'm going to identify. So A is -2. B is not 7. B is actually 0 because there's no x. So another way you could write this is -2x squared. plus 0x plus 7. And c is 7. All right, so let's take care of the first part. Is that a minimum or maximum? If a is negative, we're going to have a maximum. Okay, the axis of symmetry is going to be x equals our h number. So we got to find our h. It's not given to us, so we got to do negative b over 2a. All right, so negative b is 0, 2, and a is negative 2. So we have negative 0, or just 0, over negative 4. 0 divided by negative 4 is 0. So our axis of symmetry is right at x equals 0. Now the vertex, we know is going to be at 0, comma, because our vertex is always at hk. We just figured out h is at 0, and our k is going to be our f of 0. So we're going to take our equation, and we're going to replace the x with the 0. Okay. So we got negative 2, 0 squared plus 7. Okay, so that would be 0 squared is 0. 0 times negative 2 is 0. 0 plus 7 is 7. Oh my gosh, I wrote k. So our k is 7. So if we had to graph this, what we would guess the vertex is at over 0 up 7. That's where the axis of symmetry is, and we know this is a maximum. So we should have a sad face parabola. Tomorrow we'll talk about how can we make this a little bit more accurate, but right now this is what we're going for. All right, let's check. Let's do the next one together. If you want to pause this video, you can. And then after we do this next one, we're going to check our answers on a graphing calculator, see if we did this right. All right, let's see if you did number 4 correctly. So let's identify A, B, and C. All right, A would be 1, B is negative 8, and C is 9. All right, so first off, A is a positive number. It makes a happy face, but the vertex is a minimum. The axis of symmetry is always x equals h, and we got to find h by doing negative b over 2a. All right, so negative b is negative 8 over 2 times a is 1. So negative 8 turns out to a positive 8. 2 times 1 is 2. And that means 8 divided by 2 is 4. So our axis of symmetry is going to be x equals 4. So, if we were going to graph this, 1, 2, 3, 4, that's where we're going to have our nice reflection point. Where's our vertex going to be at? We know it's going to be at 4 something. And to figure out what k is, we're going to have to plug 4 into the equation. So we're going to take our equation. We're going to replace both the x's with a 4. So what's 4 squared minus 8 times 4 plus 9? All right, 4 squared is 16. 8 times 4 is 32. And then plus 9. All right, so if we add those together, that's negative 16 plus 9. Negative 16 plus 9 is negative 7. All right, so that means we'd have a point down here at 4, negative 7. And we would have a minimum, so that means everything else from beyond there goes up. Okay, let's check our answers here and kind of leave this a mess here, but let's see how well we did. Our first equation, we had y equals negative 2x squared plus 7. And if I just click on this graph, it's hard to see, but yep, we have a sad face at 0, 7. Oh, there we go, center the graph a bit. There you go, at 0, 7, that's what we drew. Cool. And the other one here, we had 1x squared minus 8x plus 9. All right, and we have a vertex, a minimum, right here at 0, negative 7. One more thing I need to add to this, and I forgot. One thing we can also talk about is the range. If you remember domain and range, the domain for all parabolas are always going to be all real numbers because the graph can go all the way to the left and all the way to the right. The problem here is the range. The range does have like a low and high. So in this problem here, the lowest this graph goes down to is negative infinity, okay? Because it can keep going down, 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 and go down to the lowest number possible, which is negative infinity. The highest this graph goes to, well, if you think it's a maximum, would be 7, all right, 0, 7. This problem here, the range, the lowest this graph goes to is right down here, which is at negative 7. So you can see here, like our k's are going to be parts of the range. And the highest this graph goes to is positive infinity. Keep going up. So when you look at range, you are going to use your k value, but it's either going to be negative infinity k if it's a maximum, or k positive infinity if it's a minimum. Okay, so I believe you guys have a couple assignments to do here, and I'll check you guys out on the next stuff. Thanks for watching. Have a good one.